Right.
Okay, what can I do for you? Good to see you.
Okay, so um, obviously I'm working on chapter 6. I've been trying to practice and work on homework 11, well, special homework 11, and I'm stumped on number 4.
Ah,
Let
proving
I
that
don't know.
something is the empty set.
Yes.
So it's a worksheet for people that are Monday, Wednesday, but it's
hmm
homework 11 for people that are in Tuesday, Thursday. So I'll just label it like
Yes, I'm in
that.
your Monday, Wednesday.
Yeah, I
Oh, okay.
know. Okay, so let's look at number 4. It says
Okay.
to prove we've got a universal set, okay, sort of in the background.
Yes.
So we are asked to prove this statement. If
Yeah.
A is a subset of B and B is a subset of C complement, do you know that that's what that means? C complement?
I did not know that. I thought that was square root. Like, okay, compliment. Let me label that.
Complement of the set. Then A intersect C equals the empty set. So that's what we're going to try to prove. The fact that you didn't know that this was complement, that just means you need to go back and look at the class notes from section 1.2, which was way back on like day 2,
Yeah.
and also, use your book and then the class notes on 6.1.
Yes.
Now, you didn't miss class. You were in every class, right?
Yes, I've been in every. Yes, I've been in every class.
That's what I thought. So let's just review. You know what
Okay.
subset means, right?
Yes, that means elements in A are no elements in B are going to be inside of A.
Nope, other way around. Let's do a little
Oh,
review.
elements. Okay.
Here, take a deep breath.
Elements of yes.
Okay, so for
Elements
sets
of B will be in A.
A and B in a
hmm
universe, which is every element in play, U. Okay, so the definition A is a subset of B means for all X in the universe, if X is an element of A, then X has to be an element of B. It's an if-then definition for subset of, okay?
Gotcha.
All right, sometimes we just write it like this. X element of A implies X is an element of B. This is, kind of the shorty version. So everything that's in A is in B. Okay. Then
Okay.
the definition of set complement, A complement is the elements X in the universe such that X is not in A. So you can just think about it this way.
So all the elements that aren't in A,
That's
basically.
right. A complement
Okay.
is the universe, but subtract away A. So if we were
Because
going to like,
I've done it throughout, but it's been hard to word. I'm sorry to cut you off.
no, you go ahead. Go ahead. So if A is a subset of B, like here would be set B, and A would be inside of B.
Okay.
And here, A complement, if this is the universe and this is set A, A complement is everything in the universe but outside of A. So I've shaded A complement. Does that help?
That yes, it does.
Uh-huh. Right. So we can also just look at some quick examples of sets that we're familiar with. The integers are a subset of the reals, right? Every
Yeah.
integer is real. The even integers are a subset of the integers. Remember, this means the even integers.
Yep.
Or if you wanted to play, little finite games, the set containing 1 and 2 is a subset of the set containing 1 and 2 because every set is a subset of itself. Or you could go a little bigger with the superset. The set containing 1 and 2 is also a subset of the set that contains 1 and 2 and anything else, including 3. Okay?
Okay.
All right. So let's take a look at this statement that we're asked to prove. Notice it's an if-then statement. It's an if P then Q type statement.
Okay.
And it's a statement where we're asked to conclude that a set is empty. So let's just review the basic strategy for proving a set is empty, okay? And then we'll use that strategy to attack this using a direct proof, where we assume the hypothesis, namely that A is a subset of B and B is a subset of C complement. And then our wish will be to prove that A intersects C is empty. Okay, so let's just review the strategy for proving a set is empty.
Subset B and subset C.
So let's say we wish to prove X is empty. Okay,
Okay.
so step one, use contradiction. Assume X is not empty. And then step two, take an element, little x, in set X, which we know exists because we've assumed big X is not empty,
Mhm.
and get a contradiction. And the contradiction will come from the rest of the hypothesis. All right. So,
Okay.
so let's take a look at what our hypothesis will be if we're going to prove this statement by contradiction. Okay.
Okay.
So back to number 4. I'll just write it here.
Okay.
A subset of B and B subset of C complement together are supposed to imply that A intersects C is not empty. Okay, do you agree that that's another way to write it?
Yes, that's appropriate.
All
I
right.
like that. I like that way.
Yeah, I do too. So here's our P, here's our Q, and to prove if P then Q directly, we would assume P and prove Q follows. So I think I made a mistake a few minutes ago and I said we would prove it directly. We're not. We're going to use proof by contradiction. I apologize. we always use proof by contradiction if the game is to prove that a particular set is empty. Use contradiction. All right, so we assume the negation of this statement. So let's just give ourselves the sets to set it up. No pun intended. Assume U is the universe, okay?
Okay.
And then let A, B, and C be subsets of U. So that just sets us up so the reader knows, oh, okay, we're playing games with the universe called U, and we are going to also play games with sets A, B, and C. All right, so step one, assume X is not empty, but we're going to use contradiction. So we're going to assume the negation of P implies Q. That's more than just not Q. What is the negation? Oh, did I write this wrong? Is this a typo?
Yes, because of the equals, it's not equal.
Yeah, we're supposed to put it is equal because we're
Yes,
trying to prove that A intersects C is equal. You can tell it's late for me tonight. It's not even that late, but
uh,
all
same
right.
here.
So we're going to assume P and not Q. Do you remember that that is the negation of if P then Q?
If P then Q, yes.
So we'll
P.
assume, yep. So we'll assume P and we'll assume the negation. The negation of A intersects C is equal to the empty set will be that A
Mm,
intersects C is not equal to the empty set. So here we go. We're going to assume P. So assume A is a subset of B and B is a subset of C complement and the negation of this. So the negation is that A intersects C is not empty. Okay. And then step two is to take an element from this set that we have assumed is not empty. See, we've got three pieces of hypothesis here. And we're going to use this one first. Okay. I don't know which one of these two we'll use next, but I know for sure, and this makes it a little easier for you. You know for sure you're going to assume that we have an X that is in A intersects C. We can assume that because we've assumed that set A intersects C is not empty.
yeah.
All right, so take an X that's an element of A intersects C.
Mm,
What do we wish? We wish to show a contradiction happens, right?
okay.
That's always the wish when we're proving proof by,
Contradiction.
yeah, always. It's kind of makes it, at least that part of it, a little bit easy.
Mm,
All right, now let's break down what that means.
okay.
Did I write the problem down correctly? Is it A intersect C or is it A intersect B? Is it A intersect C?
It is. I had the paper right here.
Yeah, we're good. We're good.
Okay.
That's right. I got scared for a minute. I see it now. All right. So do you remember what the intersection is?
Yes, I know the intersection.
All right. So tell me what this means. By definition of intersection,
By definition of intersection, you're saying that no, yeah, no, C and A have the same, not the same, but have elements that are the same.
yes. And in fact, we just grabbed one of them. So,
X.
yeah. So what does it mean to say X is an element of A intersects C? By definition of intersection, what does this mean? This means what?
This means X is an element of A and an element of C.
Exactly. And X is an element of C. Go ahead and write the complete sentences. Don't
Okay.
just write and element of C without putting the X. See what I mean?
Yes.
Like that would be bad form. Okay, so we've got that X is in A, and we have that X is in C. That's as far
Hmm.
as we can break this hypothesis down. We can't break down that X is in A any further, but, and we can't break down that X is in C any further. But we haven't used this hypothesis that A is a subset of B yet, and we
Hmm.
haven't yet used this piece of hypothesis. Now, we don't see anything to do with B here, right?
No, nothing would be.
But we do know that X is in A, and we've assumed that A is a subset of B.
It
So,
oh, and it, yeah.
so what does it mean?
That means if A is a subset of B, then B is a subset of, of C complement C.
No, no, no. These two pieces have nothing
Or
to
did I
do
move
with
too
each
fast?
other, really. These are independent of one another.
Okay.
I'm just
Okay.
saying we know X is in A, right?
Yes.
Because it was in A intersects C.
Yes.
Well, A is a subset of B. So
Yes.
if X is in A and A is known to be a subset of B, like everything that is in A is
Mhm.
also in B, then what do
B.
we know about X?
X is an element of B.
Right. So let's write that down. Since X is an element of A and A is a subset of B, we have that X is an element of B
Yes.
by definition of subset. This is the first thing was by definition of intersection, but now this is by definition of subset,
Okay.
right? Because A is a subset of B. Does that
Yes.
make sense?
Yes, ma'am.
Great. All right, now let's take a look at where we're at. We've used this. We used that at the beginning because we grabbed an X that was in there.
Hmm.
Now we've used this, okay, to get that X has to be in B. Well, look what this middle hypothesis says.
Okay.
It says B is a subset of C complement, right?
Yes. C.
So can you tell me in your own words what that means that B is a subset of C complement?
That means C complement has elements of B like in it. Or
Yeah,
yeah,
but
that's
uh, but it's a stronger statement than just that. It's not just that C complement has some elements that happen to be in B. Every element that is in B is in C
mhm,
complement. B is completely
right.
contained inside C complement. If X is in B, then X is in C. Let's review our definition of subset.
Mm.
Definition of subset. A is a subset of B means if X is in A, then X is in B.
Mhm.
Well, we already used that. X was in A and it put X into B. But B is a subset of C. Well, we'll put B here and put C complement. Put B here and put C complement there. It means if X is in B, then if B is a subset of C complement and we know X is in B, where does that force X to live? You're muted.
Hello?
Hello, can you hear me?
Yes, there we go. So I don't know what just happened. So yes, we was on
Did,
subsets.
did I just break up or something?
No, I think that might have been me. I think my Wi-Fi went down for a second.
Could
I
be
should be
mine.
good.
All right, listen.
Okay.
We took an element X from A intersects C, right?
Okay, yes.
And that put it in A and in C. We've got X's in A and we have X's in C. Then, as you pointed out, since A is a subset of B and
Yes.
we have that X is in A, and A is a subset of B, that puts X into set B. You with me?
Yes.
Well, similar reasoning, every element of B has to be in C complement, right? Because
Yes.
B is a subset of C complement.
Okay.
Well, that includes this X right here. This
Okay.
X is in B. So where does this X right here that we grabbed right from up here at the beginning, where does this X have to live? Because this X is in B, and B is a subset of C complement.
It has to live in C complement as well.
Right. So let's write that down. Since X is an element of B, and B is a subset of C complement, we have X is an element of C complement by definition of subset
Subset.
again.
Yes. Okay. Yes.
So now we've got that X is in C complement. X started out in A and in C, right? Because
Yes.
it was in A, we got it in B because A is a subset of B. Because it's in B, we got it in C complement because B is a subset of C complement. So right now we have that X is in A, right? And
Hmm.
X is in C complement. Do you agree?
Yes.
Well, what does it mean to say X is an element of C complement?
That would also mean, oh, I just wrote that down on the back. That means X is, how would I word this? Because it's always my wording.
Well, let's look at the definition.
Okay.
If X is in A complement, that means X is not in A.
Hey.
So if X is in C complement, what does it mean?
Then it's not a C.
It's not in C.
It's not
So
in. So,
now,
okay, go ahead.
right, X is an element of C complement means X is not an element of C by definition of what?
Not subs. Complement.
Yep. Now let's take a look at what we've just found. We've got that X is in A.
Mhm.
That's where it started out. It also was in C.
Yeah.
So we've got X's in A and we have X's in C. But now, because X was in A, we pushed it into B by definition of subset, and then X got pushed into C complement by definition of subset. And now we have X is not in C. But look right here. Can
Okay.
both of these happen? Can X be an
Mm,
element of C and also X not be an element of C?
no.
That's the contradiction we're
Diction.
looking for.
Okay, gotcha. So, by definition of contradiction, X cannot be an element of C. Oh wait, yeah. Wait.
We don't usually say by definition of contradiction, although you
Okay.
could. But the point is, let's just tell the reader exactly what the contradiction is.
Okay.
We now have X is not an element of C, but we also had what?
It's not an element of C, but we also have X is a element of C.
Yeah, X is
Yes.
an element of C. This is a contradiction because we cannot have a statement and its negation both be true. See, these statements are negations of one another.
Yes.
Like, the negation of X is an element of C is that X is not an element of C. We can't have both of those. So we conclude if A is a subset of B and B is a subset of C complement, then in fact, A intersects C has to be empty. Because the minute we grabbed an element of A intersects C, that element was an A.
Yes.
And that put it in B by definition subset. That put it into C complement, but it
Mhm.
was also in C from this very beginning part. So it got to be in C and in C complement. You can't have it in both.
No,
So that's the game with proof by contradiction of,
non-empty.
yeah, yeah, when we're trying to prove a set is empty, we assume it is non-empty, right? We assume it's non-empty, and then we get a contradiction.
And I would use contradiction each time if it's a non-empty set.
Every time you're trying to prove a set is empty, the strategy is always to try to get a contradiction.
Okay.
Always. Like the
Oh.
strategy is right here. If we want to prove some set is empty, call it X, use contradiction and assume it's not, and then take an element from it because we know that element exists because we assumed it's not empty, and then get a contradiction from the other parts of your hypothesis. In this case, the other part of the hypothesis was P. The not Q was the assumption that X isn't empty. A intersects C is our X here.
Mhm.
Does that make sense?
Yes, it does make sense.
Yeah. A intersects C is the set X that we're talking about, in this problem. It'll be a different set in other problems.
Hmm. I think.
Now,
Okay.
were you at our big long 2 hour plus office hour on Wednesday
Hey.
night?
No, not Wednesday night. I was at work.
Okay, so this is my best advice to you
Okay.
is to watch those office hours from Wednesday night
Yes, because you covered like
because we
5 chapters.
covered, yeah, we covered chapter 5 and what we talked about 6-1. We talked about homework 10 for you. It was a worksheet for
Yes.
it was Tuesday, Thursday, but for y'all it was homework 10. I've had to kind of trade back and forth with those because we back up against a test, you know.
Mm.
So the worksheets are when I don't have the possibility of grading a special homework. I just call it a worksheet and you work on it.
Yes.
So yeah, check that video out for sure
Yes.
because we covered that the stuff from homework 10 uh, that you had turned in on Wednesday.
Yeah. Okay.
Do you
Okay.
have any other questions, burning questions before we go? I can give you a little more of my time now if you need some help with something in particular.
In particular, I'm trying to think. I don't believe so because any other questions I'll have for the chapter 5, I'll just look back at older notes and the previous
Yeah, sequences,
office hour.
guessing a formula,
Yeah, and I'm pretty strong
expanding,
on sequences.
great. And,
So
expanding and evaluating sums and products. And then we had our little
yes,
formula, and then proof by induction, of course.
yes, that one
And
I had a challenge on, but I went to your coach class on Tuesday when we went over that.
and then in choose R and partition, definition of a partition, right? That
Yeah,
was that we covered that in the Wednesday night office hour because that was in your homework 10.
yes, it was homework 10.
And you also had a bunch of WebAssign, where you had to do, pairwise disjoint and disjoint sets, and the union had to be the whole big set that you're partitioning up. So review that and definitely, just also in that office hour, I explained how to maximize your points. Um, if you're struggling with the algebra of the inductive step,
Yeah, yeah. I took notes on that too. Try to like shorten my because my problem is I just wording. Like discrete mathematics has been somewhat of a challenge for me because the best thing I like about math is I don't have to write too many like letters or words.
sentences, right. But in fact, you
Yeah,
need to learn to write. properly
Yes.
using both mathematics and English because one of these days you're going to be working for somebody and you're going to need to be able to write up, what clients want or document your code or document how you set a network up or document like a help call that you then answered. Like you do need to learn to write properly.
Yes,
So
ma'am.
this is an attempt to kind of help you get back to writing. The problem, of course, is that you're used to texting and doing all kinds of social media stuff, and then you lose uh, the basic skill of just writing good English. Have you taken your English course and your upper level English course that you need for your major?
Yes, I have. I took English. I believe it was 307. I took that not last semester, last year.
What is 307? I know 310 is writing argument. What is English 307?
English 307. From what I gathered, it wasn't writing arguments. We were reading certain books, like the chapter book Candide and whatnot. We were reading the books and simply writing about each book. I don't nothing specific such as arguments. Um, but
Interesting.
that's what I gathered anyway. It was online. I was
Oh,
yeah,
so okay. And then you
yeah,
submitted what you wrote. What did
yeah,
you
and
just
then you
type
would
it
write,
in or
yeah,
something?
write essays. It was primarily how to like format papers mainly properly.
And to reference different pages and things
Yes,
with your quotes that you were pulling out to make your point and that sort of stuff,
yeah,
footnoting and all that.
got it to the T. Wow,
My mother was an English teacher.
nice.
Uh-huh. You're right. Well, listen, Tyler, I'm so glad you came into the room because of you. Folks are going to get a little recording. So
Oh,
you enjoy that Wednesday night recording. It's like a couple of hours. So you
okay,
should be able to listen to it double time and slow it down where you really need to.
got it.
All right.
Okay, you have a good night, Professor Good. I'll see you tomorrow.
I'll see you tomorrow.
All right.
Good night.